Finally, with the introduction of the RT bolt ceramic probes, measurement of bolt load during operation, even at extremely high or low temperature, is now possible. This video will demonstrate how the bolt load can be measured using a ceramic probe and our temperature demonstration unit. The demonstration unit consists of a 3/4 inch bolt that is either heated by an induction heater or cooled by a -50-degree hydrocarbon spray. The temperature is recorded by a thermocouple attached to the bolt and load is applied with a small hydraulic cylinder. The first demonstration we will do is to demonstrate that the RT bolt gauge 0 is not affected by extremes of temperature. We will do this by leaving the bolt unloaded and first cool the bolt to below freezing. Then heat it up to around 270 degrees Celsius or 550 degrees Fahrenheit. The goal is to demonstrate that the gauge reading remains at 0. So, we first zero the gauge in the bolt and then remove it before heating or cooling the bolt. We then apply the cooling spray to the upper section of the bolt, and you can see that the bolt temperature is now decreasing down to below freezing. Once cool, we insert the RT bolt gauge, and you can see that there is an initial offset due to the outer tube of the gauge cooling quicker. However, as the gauge pin cools to the same extent, the gauge quickly returns to 0 and remains there. So we have demonstrated that cooling has no effect on the bolt 0. But what about heating? We remove the gauge and then apply heating to the bolt using the induction heater. And you can see the bolt temperature rising until it gets to around 300 degrees Celsius or 575 degrees Fahrenheit. Now the bolt is at a fairly high temperature. We insert the RT bolt probe, and once again there is an initial offset in reading, which quickly reduces back to 0, then rests at 0 once the probe is at a uniform temperature. If we remove the probe and reinsert it, because the probe is already warm, the initial 0 offset and time to return to 0 is reduced. So now we are going to demonstrate that if we increase the bolt load, the gauge still functions as it should. A hydraulic cylinder can load the bolt to about 20 kSI or 140 MPa, so we will leave the probe in place and tighten the cylinder gradually. As you can see, the gauge continues to measure the increase in bolt load even with the high bolt temperature. And the beauty of the ceramic probe is that it prevents heat conduction into the body of the gauge, and so there is very little risk associated with holding and measuring the bolt load with the probe. We also have electronic probes in ceramic that can be left permanently in the bolt for continual bolt load measurement purposes. So, we have demonstrated that we can measure bolt load accurately at both freezing temperatures and at very hot bolt temperatures. In fact, we could use the RT bolt system at much hotter or colder temperatures than we have demonstrated today, as we were limited by our demonstration rig rather than the capability of the RT bolt system. We hope that you have enjoyed this demonstration of the very real advantage of RT bolt and look forward to working with you in the near future using RT bolt to solve your most difficult bolting problems. RT bolt. Simple, accurate, robust.